Hi, welcome to this tutorial on economic order quantity. EOQ is an important part of inventory theory and one of the oldest production scheduling models. We use a formula to calculate the best order size that balances the cost of holding the inventory with the cost of placing orders for inventory. The EOQ model applies only when we have regular consistent inventory demand for the year, when we have a fixed cost for placing each order, as well as a cost for owning the inventory items throughout the year. Also, we assume that the cost of the item is fixed, our lead time is constant from our suppliers, and that the whole batch is arriving on time. There are two types of basic inventory systems. The first one we'll call a fixed order quantity system, or a Q system, or an EOQ system, which is the topic of this tutorial. In an EOQ system, we always assume we have a perpetual or running inventory system, so we always know at any time how much stock we have on hand. Whenever there's an inventory withdrawal, our inventory is updated. We call this system as being event triggered, which means when we reach a certain reorder point, we will place an order for a consistent number of units. So for example, whenever our inventory of a particular item reaches 10 units, we would automatically place an order for 50. The second type of inventory system is a fixed time period system, or a P system, or a periodic review system. In this type of system, we don't necessarily have a running inventory. Instead, we call this system as being time triggered, such that every week or every month at the same time, someone will go into the stock room and evaluate the amount of inventory on hand, and then they'll place an order depending on the result. The order might be small if the usage or withdrawals have been low, or it might be a larger order if the inventory has been significantly depleted. With the fixed order quantity inventory system, we can calculate the very best order size, which is our economic order quantity. The information that we need to do this consists of, well, first we need to know the annual demand quantity represented as D. We're assuming that there is a regular, consistent usage of this inventory item over the course of the year, and that we're able to calculate the annual demand for the item. Now, sometimes in your homework problem, it might be expressed as an annual usage or even an annual sales figure. If you are given a problem with either of those terms, you can assume that that is the same as demand. The second thing we need to know is the order cost, also known as the setup cost, or S. If we purchase our inventory from a supplier, then every time we place an order, there's a cost associated with that, mainly consisting of staff wages, the systems, any expediting or follow-up that's needed. If we manufacture the inventory ourselves, then the order cost would simply be our setup costs, and those include the costs incurred in the equipment and tooling needed to get ready for our production run. The third item we need to know is our holding or carrying costs. And those are the costs to hold one inventory item in our stock over the period of 1 year. For this, we take the interest or carrying charge and multiply it by the unit cost expressed as IC. And then the formula, which I pulled up a second ago, to calculate the EOQ is the square root of 2 times the setup cost, S, times the annual demand, D, divided by the holding cost, I times C, where I is the interest cost to carry the item, and C is the unit cost. So let's do an example. A company purchases an item for $8 per yard, and that can be a yard of just about anything, carpeting, flooring, whatever you want it to be. But the yard is the same thing as a single unit. The annual usage is 360 yards per year. The setup costs or ordering costs are $10 per order, and the interest carrying charge is 25% per year. What is the best order size, or Q? Well, before we solved for Q, remember we said we needed three things. We needed to know the annual demand, the setup or ordering costs, and the holding costs. So in this example, D is given to us as 360 yards per year. The setup or ordering costs are given to us as $10 per order. And the holding costs, well, we have to compute that, but the interest is given to us as 25% per year, and the unit cost is given to us as $8 per yard. Now that we have the formula to find Q, the optimal order size, and we have all the data to plug in, let's come up with our answer for Q. Before we do that, let's review some basic math principles about the order of computations within a square root sign. Remember first to perform all the operations within the numerator, then the denominator, and finally, you want to take the square root as the last mathematical operation. So let's plug in the numbers from our example. Looking at the numerator first, we've got 2SD, or 2 times 10, which is our setup cost, times our demand of 360 yards. And we divide that times our interest times unit cost of 25% expressed as 0.25 times our unit cost of 8. So if we do the numerator computations first, we arrive at 7,200, and the denominator computations, we arrive at 2. When you divide 7,200 by 2, you arrive at 3,600. Now you're down to a single number, and you can finally take the square root of that, which happens to be 60 yards. Our optimal order size, or Q, is 60 yards. Now that we know our economic order quantity of 60 yards or units, we can determine how many orders to place throughout the year so that we have sufficient inventory on hand. And we do this by taking our annual demand, D, of 360 yards or units per year, and dividing it by our order quantity, Q, of 60 yards per order. And this gives us 6 as the number of orders to place during the year. Now, alternatively, if we wanted to figure out how often we should place the orders for inventory, we would do that by dividing the number of days in a year by the number of inventory orders made in a year. That's 365 days divided by 6 orders per year, and that tells us we need to place an order every 60.8 or 61 days when rounded up. By doing this, it means we can ensure that we have an evenly spaced number of orders 6 times a year. Now that we know how many orders we need to place during the year, the next step is that we can calculate our annual ordering or setup costs. And to arrive at this number, we want to multiply the number of orders made during the year, which is 6, by the ordering costs, which are given to us as $10, and we arrive at 60. Now the text has another formula for it, which is really the same thing as what we've done. I've just simplified it above, but it's SD over Q, and that will give you your annual order costs. Remember I said at the beginning of the tutorial that we want to use the EOQ model to find the very best order quantity that will balance the ordering or setup costs with the holding or carrying costs. Now we just calculated the setup costs as $60. Let's see how it compares with the holding or carrying costs. The formula to compute annual holding costs is the order quantity divided by 2 multiplied by our holding cost per unit. Let me talk a minute about why we use Q over 2 to figure out the average inventory. We can assume that at any given point in time, we will tend to have about half of our order size on hand in between our orders. That's called the order interval. And at any given point along the x-axis, which is time, we can make the assumption that average inventory can be determined by taking the Q divided by 2, resulting in 50% inventory. Okay, so let's see what happens when we want to compute the annual total holding costs with our example numbers. Remember, the formula for holding costs is average inventory, or Q divided by 2, multiplied by the unit holding cost, which is interest times unit cost. So we have a Q of 60 divided by 2. That gives us 30 as our average inventory at any given time. And then we multiply that times our holding cost of $2, which was I times C, right? The 25% times the $8 unit cost. And now we arrive at total annual holding costs of $60. Well, the setup costs were also $60. And if your first thought is, how is it possible that these are exactly the same? Well, then your instincts were right, and let's talk about that for a minute. In order to understand it, let's take a look at the total cost graph. On this graph, the x-axis represents the order quantity size from small to large, and the y-axis represents the cost from small at the bottom to large at the top. The sloping brownish line is the annual ordering costs, which we will get to in a minute. First, let's take a look at the downward sloping curved line, which represents the ordering costs. Notice if our Q size is very low, which means it's the Q size would be on the left side of the x-axis. That means in order to carry the right amount of inventory, we have to place a lot of orders during the year, pushing our total annual ordering cost up. Conversely, when the order size, the Q lot size, is high, we can place fewer but much larger orders, but that pushes our ordering costs down. Now let's take a look at our carrying cost, represented by the upward sloping, that 45-degree angle line, kind of splitting the rectangle in the middle. Note that has more of a one-to-one relationship as opposed to an inverse relationship of cost versus lot size. As our order size gets bigger, it follows that our average inventory will get bigger, as well as our annual holding costs. The more inventory we hold, the larger the carrying cost. Now that you understand that, let's start focusing on the total cost line, the curved brownish line. This is the combination of the two previous lines discussed. It's a combination of the carrying cost and the ordering cost. Right in the middle of the curved line, at the very lowest point, where I just put the X, notice that if you look at the dotted line down to the x-axis, that the point on the x-axis, or the Q point, happens to be the same exact amount as where the other two lines intersect, the carrying cost and the ordering cost. This order amount represents any determined Q or economic order quantity, and that's why when we used an order size of 60 in our earlier example, both the ordering costs and the holding costs were exactly the same. Let me state it a little bit differently, which is because we first figured out the optimal Q or order size, we did that in order to optimize the ordering costs, or balance, I should say, balance the ordering costs with the holding costs, right? We don't either want to have too much inventory, which would give rise to high carrying costs, nor do we want to have too many orders during the year, which would give rise to excessive ordering costs. It stands to reason that this EOQ model is trying to find the lowest cost where the two lines intersect, and that lowest point is also the optimal order size. If the two amounts are not the same, your ordering costs and the carrying costs, or pretty close to the same, then you likely have computed an incorrect Q. The final thing for us to do in an EOQ problem is to calculate the total annual cost, which is simply the sum of the ordering costs and the holding costs. Okay? And again, if we plug in our numbers from the model, we already calculated our order or setup cost is $60, and we already calculated the number of orders made during the year is 6. And so anyway, the order costs, sorry, this isn't the order costs are $60 based on the bullet that you just saw, and then our setup costs, the holding cost, is our average inventory, or Q, divided by 2 times the holding cost per unit. We already calculated that to be 60 as well. Total costs, which are the ordering costs and holding costs, is the 60 plus 60 for a total of $120. As already stated, at the EOQ, or the optimal order point, ordering costs should closely match, if not exactly equal, the holding costs. We're just about at the end of the tutorial. Let me make a couple of notes to you about your homework assignment. It's possible, depending on which problem is assigned to you this semester, that some of the figures might be given to you not in annual terms. Like they might give you demand for the month. So if that's the case, you'll need to convert any figures, like monthly figures or weekly figures given to you, to annual costs. If it's monthly, multiply times 12. If it's weekly, multiply times 52. Also remember, as I said before, sometimes demand can be stated as usage or sales, but note that that would be your D for demand. So this ends our tutorial, and I hope you found it useful.